Hello everyone. In the previous video we have talked about the Transformers library and we will talk about specifically about pipeline function. And in this video we will talk about tokenization. How are they working? What are the types of it? And we will look for some Python examples. So let's start. When we were talking about the pipeline function, this was one of our examples. And we were talking about the pipeline function actually covers a lot of things about for us, like the pre-processing and post-processing. This model is getting a text like this, and it is giving us a text response. But actually, the models can't understand texts. They just know about numbers. So something is getting this text and turning them into a number so model can understand. And the model is giving an output. Then somebody is actually turning that output to a result, to a score, or to a text. And in this pre-processing step, we are using the tokenization. So this is a high level of Transformers library model architecture. This is the model, and we work with a pre-processing step with the tokenizer, and there is a post-processing step. For example, we have a raw text and we are saying season 3 of Invincible is awesome. This is our input. Then with the help of the tokenizer, we are turning this text into input IDs. These are some random numbers. Then our model is getting this input and it is giving an output, logit. It is short for logistic unit. So I was gonna say logit, but it is logit and the pronunciation. But it is actually the raw unnormalized score. So we need to actually turn it into a probability number so we can understand. So there is a function called softmax function, which we were talking about what is that in the previous video. So this function is turning that logistic unit number and it is turning to us a probability number. And there is a definition of it if you are interested in. I will share it in the description. So in detail we will talk about tokenizer in this video. There are more than one type of tokenizer and we will see how it is working under the hood. To work with tokenizer, we can import auto tokenizer from the transformers. It will get the tokenizer type from the model. It will understand what kind of tokenizer worked for that model. So however we trained that model and used tokenization type, we will get that tokenizer. So we can use the same tokenizer for that model, and auto tokenizer will find it and use that tokenizer, which was a default model for some of our examples in the previous video. And we are saying from the pre-trained, it is a pre-trained, get that model and get the tokenizer. So we are giving some kind of inputs and we are saying to the tokenizer, give these raw numbers, raw texts, and we will talk about the padding and truncation and return tensors later in the video. When we are just printing the numbers, as you can see, we have an input IDs that we told, and we have attention mask, which we will talk about that in this video as well. So don't worry. So when we do print out the shape of the hidden state, which we will talk about the hidden state right now, later in the code section, we have two batch size. 6n is the numerical representation for the sequence, and this is the hidden size, which is the vector dimension of the each input model. But when we give a different model, for example, this is sequence classification, it has two probability because it have a positive and negative, and we have two inputs. So we have 4 probability. That is why it is 2 to 2, 2 to 2. And when we print out the logits, as you can see, we have number, but it is the raw number. So when we give it to the softmax function, it will give us the probability, which is 0.4, and this is 0.9. So this is the 1 actually, and this is the 0.9. So this is the 1, and this is the 0 actually. And we don't know actually what 0 is, what is the 1 is. So when we say the model, give me the ID to label, it says the 0 is the negative and 1 is the positive. Actually, these are corresponding to our model. You know, when we are talking about the logits and softmax, this is actually how easy you can use it in your code. We will talk about in detail as well, but I want to show you the architecture under the hood a little bit. So let's get to the Excalibur again. So in here, this is a little bit under the hood. We are giving an input to the model, and the model is pre-processing that data, and it is turning them into vectors. So these vectors are in the embeddings section, and then after the embedding section, there is a sequence of layers that will get that input and it will give it to the neural networks, you know, and then it will generate an output. That output is in the hidden layer actually. Then it will give it to the head. The head is about why we are giving that input. Like for the token classification, like the sequence classification, maybe for question answering section, we have more than one purpose, and the head is why we are giving that in output. So that is why even the model is the same, the response can be changed. Then we will give the output. Like we talked in the start of the video, tokenizer are turning the text into the raw numbers, but it has more than one techniques for that. So we will talk about these techniques now. So in here we have three types of models, three types of techniques actually. So the first one is character based. For example, our word is unbelievable. When we get the character base, as you can see, we have one token for each character. But the negative side of it is when we are giving the each token, actually they are not so meaningful. Of course, we are talking about the English or most of the Latin language. For example, in Chinese or Japanese, one character means a lot of things. So character-based tokenizers actually can be useful for this kind of language. But for our Latin language, it's not that useful. For the words-based, if we have a sentence, the token will take the every word to a number. So, for example, unbelievable will be a word and it will be a token. But the cons of it is it will not understand the difference between like an apple and apples because they are just two different words. They don't have any similarity. Actually, they are just two different tokens. This is how the word-based works. And we have a third one, which I just written wrong because it is subword based. Oops. Yes, now it is true. We have a subword based. So subword based works, actually it is like the fusion of these two. It is combined. So subword based says if the word is a popular word, like the frequency is a lot, then we will not decompose that word into a smaller one. But it is a rare word, then we will decompose it. For example, the unbelievable word is 3 token, believe and able. It can change for the different models, but I'm just giving the base knowledge in here. Like in some models, it can be the V can be in the other one. For example, I don't know, but it is unbelieve and able. And for a lot of things, it can be changed. Like for example, tokenization. If it is a character based, every character is a token. For word based, it is 1 token. But for subword, it will probably be like token and isation. So it will take 2 tokens and it will keep the correlation between them as well as an additional knowledge. There is a custom token that I forgot to mention in the word-based specifically, and that is the unknown, and that is how it is written sometimes, or unknown. It is in our dictionary, we will have all the words in our models, but some words cannot be recognized. So the model is using unknown for that word, and that is used a custom token or unknown token. So let's see the tokenization in the code base. So in here, we are getting the config from the BERT config model and the configuration, and we are using the default BERT config and giving it to the model. So we are building a model actually. And when we are printing the config, we can see a lot of configs in here. We just talk about the hidden sized and we didn't talk about the other ones, I think, for now. But we will talk about the pet token ID as well. Maybe in the next videos, we will talk about the other ones as well. We are getting the model and we are saying, give it the weights of it from a pre-train because we just got the model, but we didn't train it. And train the model from the 0, it is pretty actually takes time and computation as well. So we can just get a pre-trained one. And we are saying get a pre-trained, which is BERT-based case, which is pre-trained by the authors of the BERT themselves. We are getting that pre-trained model and save it to our computer. As you can see, there is a direction in here. When we open it, we can see there are tokenizer configurations and there's a vocabulary in here. As you can see, they have a lot of words in their model. And for example, these are some extension of a word. And extension of a word is in English, there are a lot of extension words, but it is especially useful for Turkish as well, my main language, native language, because especially for subword, because for example, gidiyorsun means you are going, but for example, git is actually go, and gidiyor is going, and gidiyorsun is you are going. So this is actually the same different words. So it will be different words, different token, but in the subword, they are actually the same token. That is why the different token techniques are important and it can be changed to the model or to the language. So in here we have a tokenizer JSON. As you can see, for every word it has an ID. So when we talked about in the beginning of the video, we said the tokenizer is turning the raw data, raw text into the numbers. So in here, for example, every word has a consequence identity number. It just starts from the 0 and it is giving IDs to the words and punctuations and etc. And in here, as you can see, we have an unknown token as well. We have talked about the mask token in the previous video, and we will talk about special tokens later in the video. Okay, from transformers, when we are getting the pre-trained model, I'm just giving and saying using a transformer network is simple. Actually, this example is from the Hugging Face NLP course, which I will talk about at the end of the video. So using a transformer network is simple. And when we are giving the sequence to the tokenizer, as you can see, we got the tokens like this. Using a transformer network is simple. It is a support. And there are more than one support techniques as well. We have different techniques, and I will share some different tokenization techniques in the description. If you are interested in, you can check them as well. So converting the text to the numbers are called encoding. We have a convert tokens to IDs function. So it is encoding actually the tokens to the I numbers. As you can see, this is the corresponding numbers of these words, these tokens. And converting the numbers back to the text is called decoding. So this is the decode function. When we give the encoded number to the decode function, it gives us to the original text. We have talked about the return tensors and said we will talk about them as well. Return tensors are actually the transforms library works with PyTorch, and they are working with TensorFlow, and some models supports Flex as well. So in here we are saying return tensors for PyTorch. Tensors are basically NumPy arrays, and when we are getting the tokenized inputs, as you can see, we have the PyTorch tensors as well. So I was saying in the config section, we have a padding token ID. Let's talk about it a little bit as well. Padding token ID and attention mask. So padding token ID is, let's say this is our tensor input for the model. So our models actually getting the tokens as rectangular shape. So they need to be rectangular. So we need a padding, a space to here. So we can give it to the model. For that, models have their own numbers, their own pad token IDs. It can depend on the model. For example, for these models, it was 0. So when we are giving this ID to the model, we need to say to the model that, so that's why we have an attention mask. We are saying these are the real values and this one is not a real value. Skip that. Our padding IDs. That's why we have an attention mask. We are masking our padding IDs. So when we put it all together, we can get a model and get a from pre-trained model. So we don't train it from the ground, and we can get it the tokenizer from when we just give it the input, when we just give the text input and say get the tokenized words for this input. And we can give more than one sequence to a tokenizer, and we can say pad the sequence to the longest length, like every model have a padding max size. So for this one, this is using the maximum sequence length for the inputs, and we can just say max length. It can depend on the model, and we can give to both of them as well. And we have truncation. So every model have a truncation section. So it will just truncate some of the inputs. And we can return multiple tensors like NumPy, TensorFlow, or PyTorch. It can depend on why you are getting this, or when you don't give any specific tensor, it will return the three of them. So you can use whatever you want. And we have a special tokens for the models. So for example, I've been waiting for a Hugging Face course my whole life. And when we tokenize this input and print it, as you can see, we have the input IDs. And when we decode it again, as you can see, we have additional text in here that we didn't give in the input. That is because some models can add additional data to their input, so they can separate it, like this is the start, this is the end. They can have a different purpose. And for this one, as you can see, we have a CLC in the beginning and SEP at the end. So it says I've started and I've ended, something like that. And some models can have different kind of special tokens. But with this knowledge, you can see that when we can decode the data that we have given the input, as you can see, it is not the same. We can get a different text. That is why, because we have special tokens. And this is in a sense what tokenizers are. We are talking about the architecture of the tokenizer and transformers library. We have talked about a little bit about the models and under the hood, and we have talked about the tokenization techniques. We have talked about the configuration of the models and some code examples as well. We have a lot to learn for the NLPs, and we have a lot of things in this course, so we will continue to learn from it. That's it for this video. I will share the softmax function and the code base, the GitHub link in the description. Thank you for watching. See you in the next video. May the force be with you.